Hey everybody, in this video we are going to go over how to transform graphs, specifically exponential equations. For this video, I'm not getting too into it. I'm only doing 4 examples. The parent function using the base of 2, although you can use different bases, base 3, base 1/2, base unlimited bases. So I'm just conceptually going over things. There will be more in-depth videos on this playlist in the future, even tomorrow, a few more exponential elaborations. Okay, here, first one, y equals 2 to the x power, aka, this is important, that is the same as 1 times 2 to the x. Now, if you don't remember that the 1 is there, you could get a little confused because this is the setup. A times the base raised to the power of b times the quantity x minus h on the side plus k. So what does this all mean? The x in the power is minus 0 and on the side is plus 0, so that's your hk. It's not moved. A is 1 and b in this case is also 1. So that means calibrated, my graph is centered at the origin, but no point passes through that point, that origin point. If I fill in 0, make a little table of values, so x and y. Okay, so let's start with 0. If I fill in 0 for x, 2 to the 0 power, what is that? Don't say 0, it's 1. Fill in 1 for x. 2 to the 1 is 2. Fill in 2 for x, 2 to the 2 is 4. Fill in 3 for x, 2 to the third is 8. 0 gives me 1. 1 gives me 2. 2 gives me 4. 3 gives me 8. 4 would give me 16. 5 would give me 32. 6 would give me 64, and so on. So I'm starting at 1. This is where I'm starting. That is my initial value. Now, it's usually 1 unless you multiply it by a vertical stretch or compression. I don't realize how much I'm like leaned over writing, sorry. Initial value, and then this, since it's greater than 1, we call that our growth factor. That means we're growing by doubling every single time. Okay, so times 2 times 2 times 2. Maybe I should tilt that down since I'm constantly leaned over on the desk, sorry. So if the base is a number between between 0 and 1, it would be less than 1. That would actually be a decay factor. And if it's a number greater than 1, that is a growth factor. And again, the focus is just kind of, yeah, I gotta do that every time, I guess. Ooh, and that might be a little cut off. Yikes, so sorry guys, not my best. Forgive me. What if I fill in -1 for x? If I fill in -1, 2 to the -1 is really 1 over 2 to the first. 2 to the first is 2, so 1 over 2 is 1/2. If I fill in -2, property of exponents, it's 2 to the -2, which is 1 over 2 squared, which is 1 over 4. So 1/2, 1/4, and so on. And if I keep plugging in more and more negative numbers, I'm going to get smaller and smaller, but I'm never going to actually hit 0. So I'm going to have this little dotted line that I'm going to get really, really, really close to. That dotted line is called an asymptote. Asymptote comes from the word that means like asymptomatic. So it doesn't show any symptoms or characteristics of the graph. Symmetry, none. There's no symmetry here. 2 to the x. So as x goes to the left, negative infinity, where does my graph go? To 0. And as x goes to right, where does my graph go? Up to infinity. My dog is looking for attention. I don't know if you hear him. Domain is from negative infinity. I feel like he knows I'm talking about him. To infinity. And the range, parentheses 0 to infinity. It starts right after 0 against that asymptote forever. So again, what do we have to do? Let's look at a different example. Here's my initial value. I'm starting at 3. On this axis. I didn't shift left or right. I didn't shift up or down. So I'm calibrated around 0, 0. Now the 2 for the base tells me I double every step of the way. So this 3 doubles and I have 6. Think of it like a bar graph. The population of a city is growing exponentially, doubles every year, whatever. Then that 6
doubles and becomes 12. Then that 12 will double and become 24. Now if I want points this way, I would just take half of it, 1.5, 0.75, yada, yada, yada. And there we go. So the growth factor is still 2. However, the initial value is 3. So I started with 3. And when I grow at an exponential rate, I'm going to get higher in Y values faster. That's also why you should always negotiate for a really good starting salary, because your raises are usually a % dependent upon what you were making before. So the less you have initially, the less you'll make year after year with your raises, and the less you'll make in your lifetime. Fun fact. Okay, 2 more examples. This one, 7C, my initial value is 1. There is that invisible 1 in front. Y equals 1 times 0.5, which is 1/2. X minus 2 minus 4. This is your H and your K. So we are going to go right 2 and down 4. Right 2, down 4. Now here's the problem. There's no dot there. Don't put your pen down there. Right 2, down 4 is my new origin. And now we move our initial value up along the vertical of that, and we'll have a horizontal asymptote through the horizontal of that. So I'm going to have an asymptote here, one way or another. 1 is my initial value due to that 1 right there, okay? And then 0.5, as I go to the right, that's what I multiply by every step of the way. So that means my 1 move over is a half. Half of that is a fourth, but that's terrible. How do I graph that? Glad you asked. Go to the left one, and instead of taking half, double it. Then double 2 up to 4. Then double the 4 up to 8. And then you connect, and you made an exponential decay. Not perfect drawing, sorry. And there you go. How smart are we? Now this one is a 1 times 4, growing much faster. X plus 5 minus 3. So where am I moving? Left 5, down 3. Left 4, 5, down 3. That's where I am calibrated to. Again, that 1 in front, 1 times 4. So each bar graph, if it was a bar graph coming off of this horizontal asymptote, oh my gosh, she's barking. Dallas, one more example. I'll take you out. 4 up. And then the next one is 4, 8, 12, 16, up, times 4, times 4, times 4, and then a fourth would be here. 1/16 would be the next. And then we go. Eek. And there you have it. So this was growth. The 2 on top were growth. This is exponential decay. My decay factor is 0.5. If your decay factor is 0.5, you're decreasing by 50%, but you're also keeping 50%. If your if your decay factor is 0.7, you're decreasing or decaying at a rate of 30%. You're keeping 70%. If your base is 1.5, you're growing at a rate of 50% and resulting with you having 150% of what you started with each time you compound. If you have a growth factor of 2, while you are doubling, you are increasing by 100%. If you have a growth factor of 3, you are tripling, which means you are increasing by 200% and keeping 100%. Food for thought. Just use your noggin. Don't forget, a to the negative m, which I referenced earlier, is 1 over a to the positive m. All good to know. If you feel a little bit smart about exponential growth, give me a thumbs up. Questions, comments, concerns, put it in the comment section. Talk to each other, talk to yourself, or maybe I'll talk to you if I have a chance. The next one I'll be doing is logarithmic, and I already did linear, absolute value, quadratic, cubic, square root, cube root. This was exponential, and like I just said, next is logarithmic on the playlist. Have a great day. Bye.